Okay, so we're talking about parabolas. There's a couple different forms. There's the vertex form of a parabola, which is should be very familiar to you. Y equals a times the quantity x minus h squared plus k. The standard form is y equals ax squared plus bx plus c. That's kind of like the expanded form. I know that typically we used standard form for what we called, where you would see the vertex of the ellipse or the hyperbola or the circle. So that's a little bit different in terms of the parabola. Let's see, where else here? The vertex obviously is HK. One big point I want to make to you is there is no center of a parabola. So if I ask you for the center of a parabola, you probably should put NA because that doesn't exist. It has a vertex but no center. The axis of symmetry can be found by x equals h if you know the h value of the vertex, or if you just have a and b, it's x equals the opposite of b over 2a. Now, the distance to the focus, c is equal to the distance to the focus, has a relationship with a. Now you can use it in either one of two ways. You can say the absolute value of a is equal to 1 over 4 times that distance, or you can find that distance by taking 1 over 4 times the absolute value of a. So either way, these two formulas are very useful depending on which direction whether I have c and I'm trying to find a, whether I have a and I'm trying to find c. Now, what is a parabola? How do you actually come up with its definition? Well, take any line in the universe that you want and take a point not on that line. This line is called the directrix. It is not a part of the parabola. This point is called the focus. It is also not a part of the parabola. But these two things will actually give us the definition of a parabola. In other words, if you would take every point whose distance is the same from the focus as it is to the directrix, you'll notice those two distances are equal, and start finding all the points. If you take this distance, it should be equal to this distance. Every single point that you can find where this distance equals this distance, you will identify all the points of a parabola, of which there are an infinite number. Just going to draw you a few of them. They talk about distance 1 and distance 2, and those two things are equal, no matter which point you choose. This is how we come up with a parabola. A parabola is a set of all points whose distance from one point and a line are the same. Obviously, this one right here is my vertex. Right down here at the bottom of this, or halfway in between the focus and the directrix. The distance from the focus to the directrix, that's what we're calling C. But guess what? It's the same distance from the vertex down to the directrix. So you can see C is twice right there. Okay? So that's what a parabola is and how it is defined. And we should be able to find the directrix. You're going to be looking at different parabolas that are horizontal or vertical, okay? We've been dealing a lot in your life with the vertical up and down opening variety, but we can also think about those that open left and right. I summarized for you a lot of the information that's on this page. few seconds ago. If you need to look it over or copy something down, obviously A controls whether it opens up or down, positive being up, negative being down. But if we switch x and y, then we're talking about a parabola which opens left and right. Now, I want you to take a look at the equation. X equals A, and this says y minus k, and h is now on the outside. That's different. The standard form has x all by itself over here, and then ay squared plus by plus c. Vertex is still located at hk. That's not different. You'll notice that k is equal to negative b over 2a. That's reversed. Your axis of symmetry, y equals k instead of x equals h. That's different. And if a is positive, then we're talking about something that opens to the right. And if a is negative, you know that it opens to the left. The formula or relationship between A and C is still the same, so that formula has not changed. So if you ask me to graph, give me an equation like y equals x minus 3 squared minus 9. We can, I better zoom out a little bit there. Okay, I think I figured it out now. We can talk about the vertex being 3, negative 9. We can talk about the axis of symmetry being x equals 3. This does open up because the a value is positive, right? A equals 1. We can find the distance c to the focus and the directrix by using the formula, right? So the distance c is 1/4 of a unit. So if I know that this thing is at 3, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, negative 9, one-quarter of a unit up is the focus. That is super hard to draw on a really bad-looking graph like mine. So it's kind of hard to tell that you have, in between here and here, you have 1/4 of a unit. And that there's a line down here underneath this that is 1/4 of a unit down from that. So if my vertex is at 3, negative 9, my focus, being 1/4 of a unit above that, is at the point 3, negative 8 3/4. My directrix is a line, and every directrix which is horizontal would be y equals, and that directrix would be y equals negative 9 1/4, because you're going 1/4 of a unit down from the vertex. Now, can we plot points? Sure, we can plot points. Same way we plotted points back in Algebra 2. You've got 3, negative 9, and you can start picking values to put into your equation. What happens if you put in a 4? If you put in a 4, you get 4 minus 3 squared is, you got 1 squared is 1, 1 minus negative, or 1 minus 9 is negative 8. We know that 2 will also give us negative 8 based on the symmetry of the graph. If I plug in a 5, 5 minus 3 is 2, 2 squared is 4, 4 minus 9 is negative 5. We also know that negative 1, or I mean positive 1, will also give me negative 5. It's that whole symmetry of the graph issue where you have matching values on either side of the axis of symmetry. So we could plot those points. Not a great job, but you get the idea. When we start getting into the horizontal looking variety, that's switching things up a little bit. Let me see if I can give you an example of that. Suppose I started with x equals 2y squared plus 8y plus 5. And that was what I was asking you to graph and find all this other information about. Well, we can find the vertex, right? Or actually, we could find the axis of symmetry. In this case, it would be k equals the opposite of b over 2 times a. Negative 8 over 4 is negative 2. We can plug that in to find the h value that goes with it, right? 2 times negative 2 squared plus 8 times negative 2 plus 5. So that's 4 times 2 is 8. Minus 16 plus 5, negative 8 plus 5 is negative 3. So we have a vertex at negative 3, negative 2. This has a positive a value, right? Since a is 2, we are talking about opening to the right. So if I was just going to draw you a quick, I mean, we can make a chart. We're picking y values instead of x values, right? That's kind of different. Picking y values like negative 1 and 0, negative 3 and negative 4. If you plug in a 0, you end up with 5, so that must mean that negative 4 will also give me 5. If I plug in negative 1, right, 2 times negative 1 squared plus 8 times negative 1 plus 5. Let's see now. We've got 2 minus 8 plus 5. That's negative 6 plus 5 is negative 1. So we can plot our points on our graph. We've got 1, 2, 3, 4, 5, 0, negative 1, negative 1. Keep in mind, your axis of symmetry cuts this thing in half. The axis of symmetry would be y equals negative 2. So I guess back up here we should have written the equation of a horizontal line, y equals negative 2. We use the value of k because we know it's y equals k. So I should have stated that a little more clearly earlier. Continuing my graph, I have the points negative 1, negative 3. Oh, that's a matching point to that one. And then a matching point at 5, negative 4. And so we can come up with our sideways looking parabola. The directrix and focus, let's see here. If the a value is 2, c equals 1 over 4 times the absolute value of a, which means it's 1/8. Very hard to draw a focus inside of 1/8 and a directrix outside. But that directrix would be x equals All right, so if this is negative 3 and I want to go back 1/8, that's negative 3 and 1/8. The focus is inside the parabola, so that would be negative 2 and 7/8. Oops, sorry, where is the comma coming from? Should be after the 7/8. Negative 2 and 7/8, comma, negative 2. So you're moving to the right 1/8 of a unit. And so that's the picture in your directrix and your focus. Remember, directrix is always outside. And focus is always inside. So if you know which way the parabola opens, you're not going to have a problem finding your directrix and focus. See you in class.